Alright, in this video we are going to look at trigonometric substitution. For instance, now you know how to integrate natural logarithms, you know how to integrate inverse trig, you know how to integrate exponential functions and all that, and you also know how to do U substitution, that is integration by substitution. But what if you have integral of 1 plus x squared dx? What if you have been given a question like this to integrate? How are you going to go about it? Can you solve this by substitution? That is, you setting u to be equal to something and all that. You see, when you set u to be equal to this and you integrate this, you are going to get 2s. And 2s, how? Like how? You see, it's going to be something tedious for you. Alright. So that means that we are not done with the techniques of integration. We are not done with techniques of integration. There is another one that we need to know, and that is trigonometric what? Substitution. Alright. Why is it trigonometric substitution? But we are not having anything like trig function. There is no trig function in the question. Okay, but we can transform this to trigonometry. In what way? So, having this, we can write this as 1 plus x squared. Alright? And this 1 plus x squared is representing something. And what is that? In case you can see it well, from the idea of Pythagorean theory, that says that r squared is equal to x squared plus y squared. You can see that this is in the form by taking the square of both sides, which is the square root of this, because we can let this one be what? 1 squared. Oh, if that is the case, then when we draw our right angle triangle and represent here by theta, then this is going to represent something here. But question, we have the adjacent, the opposite, and the hypotenuse. But is it going to be a hypotenuse or side? Straight away, this is going to be a hypotenuse. Alright, this is going to be a hypotenuse because of the plus here. So this is going to be here 1 plus x squared. So what is going to be of this and what is going to be of that? Very good. So looking at what we have here, we can say that, oh well, then 1 can be here, or x can be here, or x can be here, or 1 can be here. Okay? So let's make here x and let's make here 1. Alright, good. Then we ask ourselves again, all that I'm doing is that I'm showing you the way we transform this to a trigonometric what? Function. That is what we are saying, trigonometric substitution. Alright. So we ask ourselves of a question that which trigonometric functions is going to help us to generate this in order to get s over a constant. That is s over what? A constant. And now, for instance, s over a, where the a is representing what? Any constant. We can see that it's only tan. We can see that tan theta is going to give us s over 1. Please, yes, I know that here there are a lot of formulas that some books give you, but I don't want you to go and choose those formulas. I want you to understand it and see where it is coming from, so that after that you can do whatever you like. Okay, And with this, by cross multiplication, we can say that s is equal to tan theta. So instead of writing this, we can write this as, or instead of writing integral of this, we can write this as integral of 1 plus, square root of 1 plus tan theta squared d theta. Very good. And now we have done trig substitution. I hope you can see that. Very beautiful. And if only you have trigonometric identity spectacle, you can see that the inside here is just sec square theta. Sec square theta is 1 plus what? Tan square theta. Very good. So in the same way, this integral function, we can rewrite this as integral of square root of sec square theta d theta. I hope you can see that. Alright. I forgot to also tell you something, that here will not be d theta, here will rather be dx. So to change this dx to d theta, we need to what? Differentiate this. So here we get ds is equal to, when you differentiate tan, you get what? Sec square. So sec square theta d theta. So if you want to do the substitution of this ds, in place of ds, you put sec square d theta. So here will rather be times sec square d theta. Sec square d theta. Alright. And here you can see that this will clear up this, and you get the integral of sec theta sec square d theta. I hope you can, in fact, I don't want to end it, I will come back to it perfectly. But this is how we transform a given question to a trigonometric word substitution. I hope you have enjoyed it. Alright, so let's look at it in general. It's not always going to be in this form. Let's see all the forms and deal about it. Alright, so let's see. Let's look at all the forms. Okay, so idea, this idea, so this idea that we have just looked at, work for square root of a squared minus s squared, square root of a squared plus s squared. We also have square root of s squared minus a squared. So we can get any of this form. Alright? We can get any of this form. And let's see how we are going to treat it. First of all, we have seen that if you have this, so first, we have already generalized that if you have a squared plus s squared, and that was 1, the a for that one was what? 1. But here we are using it a in general because it can be anything. Something square plus s square and s square all square root. So here we have seen that we can write this as right angle triangle. This will be the theta, and here this is going to be the hypotenuse. Now, let me explain here to you well. Now that we are in the general form, here you see having this, A can come here, A can be here, S can be here, S can be here. So how are we going to write it? Please, we don't write it anyhow. You just don't write A and you don't just write X, but we are going to think of it in this way. Watch. We are going to use sine theta. Here we use only these three trigonometric functions: sec theta and tan theta. Alright? So in the use of these trigonometric functions, which of it that when you express, you are going to get a variable over a constant. That is what we want to get here. We know that this will represent the hypotenuse, but which of these trigonometric functions that when you express, you are going to get a variable, let's say a variable s over a constant what? A. We can see that here with sine theta. Sine theta is y over r. Oh, that means that the denominator here is not going to give us what? A constant A. So this fails to this approach because the r is the hypotenuse and that can be a constant here that we are talking about. Please, I'm taking my time with this. It's very, very, very necessary. Alright. Okay. What about sec theta? Sec theta is a reciprocal for cos, and that is s over r. R over x. R over x. And having r over x will also fail to fall under x, a variable x over a constant a, because since you have r in it, it's filled because the hypotenuse is now this. So here is failing. So the only thing is that when we use tan theta, very good. We are going to have y over what? X. Y over x. So the opposite over the adjacent here is going to be a variable over a constant. So how do we get that? We know that here tan theta, and definitely we have to get a variable first on top. That is by default. We have to get a variable on top. That is by default. I hope if I say that you understand. And a constant. So you see that this variable s will now represent the y. It's not that s is here, so here is going to be x. No, I'm talking in general. This is the formula opposite over the adjacent. So you can see that here, or should I stop using y by x? Let me use opposite over adjacent. So here you can see that the opposite here should be a variable. So that, and we are saying that it should be x. The one on top should be x. So that is s. So the s is now the y value. Then a constant a. Oh, okay. So that means that is something squared, a variable. So here is going to be the a. Very good. So that is that. Then the next thing to do is to make x the subject. So you get x to be equal to a tan theta. A tan theta. And also there is also a need for you to what? To differentiate this. Because you transform it into the integral function. We will get there when we are solving questions. And whenever you are dealing with tan, you will need a trigonometric identity. And that trigonometric identity is going to be 1 plus tan theta is equal to sec theta squared. Alright, so there will be a need of this trigonometric what? Identity. I hope it's clear now. Alright, so that is that for that on that part. On that part. Alright. That is that for that on that part. Let's look at another one. The second one. Which is, so this is the first, second. Let's go for square root of a constant square minus s squared. Having your right angle triangle, is this going to be a side or hypotenuse? Don't forget here is minus. And if I say side, it means it can be here or here. So is it going to be a side or a hypotenuse? Since there is no plus at the middle there, it's going to be a side. Okay. And if it's going to be a side, then where is it going to be? Is it going to be here or there? How do we know that? Okay, no problem. We can just know that by simply thinking in that form, that which of these that when you write, you are going to get a constant over, a variable over a constant. We are still using sin theta, sec theta, and tan theta. Very good. So let's move on. Alright. So let's move on. Now, please watch me. We know that it is going to be a side. It can be here, it can be here. But now, let's find out the one that can be in the hypotenuse first. That is the most important thing. The one that can be in the hypotenuse. Because if you see the one that will be in the hypotenuse, you will see the trigonometric function that will help you to generate it in this form. So watch me. This is very technical. You know that there is no way that a distance can be negative. And you know that Pythagorean theorem uses the idea of what? A distance. And that is what? Radius. So there is no way a radius, which is the hypotenuse, can be negative. There is no way that can be what? Negative. So in such case, this can be negative. We are saying that this can be here or here. But we can see from here that A is positive and the S here is negative. One is negative and one is positive. And there is we are saying that this can be here or here. So we want to verify the one that can be at the hypotenuse first. And there is no way that the hypotenuse can be what? Negative. So definitely here is going to represent your A. And if that represents your A, then to write the one that will be here or here, we need to go by these three trigonometric identities. Which one is going to help us to do? So we are saying that here can be S or square root of A squared minus A squared. In the same way, the same thing. So the sin theta, we have already discovered tan theta here, so let's leave that. And sec theta, which one is going to help us to get a variable over a constant? Okay. Sin theta is opposite over hypotenuse. Sin theta is opposite over hypotenuse. Okay. So what is the opposite? The opposite is the one coming here. And the hypotenuse is A. Definitely that will work. That is going to work. How we can see that? Because if the opposite is X, then we are going to get S over A. Okay, let's try set, which is R over X, or hypotenuse over adjacent. Sec theta is hypotenuse over adjacent, and the hypotenuse is A. That failed to be in the form a variable over a constant. I hope you are getting this concept. So sec theta failed to be in the form x over what? A, because hypotenuse is the A, and that failed to be a variable. Very good. So sin theta will work. So sin theta will represent the opposite. So we get the variable. We get the variable. And the hypotenuse is this, and that is correct. So definitely the sine will be a squared minus 1, a squared. And that is what we here. The angle is tan theta. So here we say that sine theta is equal to this. So s will be equal to a sine theta. Alright, so when you take the derivative, we take for that one, we do it in solving the question. But you will definitely need a trigonometric identity to go and do substitution to. And what is going to be that trigonometric identity? There will be a need of trigonometric identity for you to go and do your substitution. So what is going to be that trigonometric what? Identity. Alright? With this, we can make tan theta the surface, okay? We can say that tan theta square theta is equal to sec theta, sec square theta minus 1. So that's what we are going to do a substitution to. Alright. So let's move on. So with trigonometric identity, we can write it in this form, in the same as the other one, don't worry about it. So here too, the identity that will be needed for the substitution of this is going to be cos square theta is over equal to 1 minus what? Sin square theta. So that is what you are going to be needing. I just don't want you to be chewing this. And some people chew that anytime you have this form, this will be this. Anytime you have it in this form, this will be that. Please don't chew it. You know where it's coming from, and you can play back the video. Lastly, the last one, we don't need to think too much. 3. Integral of, that is s squared minus what? A squared, alright? You know that is also going to represent what? A sine. This is going to represent a sine. But you need to indicate the hypotenuse first. The hypotenuse is always a positive. So the s will be here. Alright? But watch of it. Straight away, sec theta. Sec theta is adjacent, the hypotenuse over the what? The adjacent. And the hypotenuse is the x. So this is correct. So you can see that the hypotenuse will give you s, and the adjacent should give you what? A value. And that is a. So here will be a, and the side, this will be s squared minus what? A squared. Alright? That is that. That is that. And here is sec theta. So s is equal to a sec theta. Alright? And that is that. There will be a need of trigonometric identity. There will be a need of trigonometric identity and that is going to be, okay, yeah, and that is going to be tan square theta is equal to sec square theta minus 1. Oh, then here the substitution of this is rather sec square theta is equal to 1 plus tan square theta, as we did in the first one. Okay, so that is all. Please just play back this part and understand it before you come to join us in solving the questions. Alright? So that is that. And also note that theta here will be equal to what? Sec inverse. Theta will be equal to sec inverse. Sec inverse of s over a. Here, theta will be equal to tan inverse of s over a. Here, theta will be equal to sine inverse of s over a. Alright, so let's see how we can solve a question.